What? You mean look at my math versus scores when I didn't have school? What? Yes.
The one that's on the extra practice, 5, 5, 6.
That's the last page. Yeah. Number 5. All right, so this is, the other day, we actually did some from this page. This is extra practice. She's looking at problem number 5.
Man 6 feet tall.
Yep. And we gotta figure out something. So, a man is 6 foot tall. He's looking at a tower that is 38 feet tall. The man is 70 feet from the tower, and we want to know his angle of elevation to the top of the tower. Now, remember that angles of elevation and depression are measured against the horizontal. So I'm going to need to draw in, this would be his line of sight. I mean his like straight ahead. And this is his angle of elevation. So that's what I'm looking for, that angle right there. Now, don't make this harder than it is. That dashed line I drew in there is how long? 70, isn't it just like this one? So that's 70. And this piece of the triangle right here would be how much? 32. So all this is kind of not important now. I am finding this angle in this triangle. Make,
Wouldn't that be a right angle because of?
this is.
Yeah.
So you could do what? Absolutely, SOHCAHTOA. You could also do the, no, I think that's what I'm gonna do is SOHCAHTOA. So I'm gonna say, what, tangent equals 32 over 70? And then how do I put that into my calculator? Second tangent, right? So I'm gonna second tangent, inverse tangent, 32/70. And whatever that is, I gotta be set in degrees. So second tangent, 32/70. That angle is 24.57 degrees. Okay, Katie, got it?
Yep.
All right, who else? Anybody else find something? I did want you to pay attention to the fact that these other sheets are actually called pre-quest. And there's 2 of them. One has more questions on it than the other one does, but we should probably focus our energy on those since those are the quest problems. Okay? So here we go. Anybody see anything on either one? I don't care which one. Peter?
Quest 5556 number 5. Jordan's walking.
Okay.
Towards the tree tower.
Okay, so it's another lower problem, kind of like this one. Only what's happening? So here's the tower. At one point, her angle of elevation is 28 degrees. After walking 15 more minutes at a speed of 2 miles an hour, her angle of elevation is 31 degrees. How tall is the building? Now, the thing here is, guys, you have got to be able to recognize, you know this distance. She's walking 2 miles an hour for 15 minutes. So how far did she walk? What? Half a mile, that's right, 0.5. Distance equals rate times time. She's walking 2 miles an hour for a quarter of an hour. So 25 times, 2 times the fourth, 1 half. All right, do I know anything else about anything in there? If this angle's 28 and this angle's 31, do I know this one? What's that one? to?
Oh, 149.
149? And if that one's 28 and that one's 149, then the skinny little one right here is, help me out, 3? Could I use the law of signs to find this? I'm gonna call that H. That is not the answer. But here's the dilemma, folks. We did this problem in another chapter. We set up a system of equations. You can still do that. But you can't use 28 and 149 and 3 and 31 in the same equation. Because that 31 belongs to this triangle, and these angles all belong to this triangle. So you can't set up a law of signs with both of these, for example. That's not possible. You gotta stick within the same triangle. So I'm gonna say sine 28 over h equals sine 3 over 0.5. Now, is that solvable? Yeah. I can get h. Now, h isn't the answer to the question, but coming over to this triangle, can I say sine 31 equals x over h? And once I have found my h, I can multiply it times sine 31 and get the height of the building. Would you, or get the height of the building. Would you agree with that? Okay. Any way you do it, this is going to be a two-step problem. When we did it before, see if you remember this, we said something like tan 31 equals x over y. And then tan 28 equals x over 0.5 plus y. Remember that? Those were kind of complicated. We did it that way. No need to do it that way now. We can use the law of signs. So 0.5, wait a minute, I gotta make sure I'm in degrees. I'm not. Okay, so 0.5 sine 28 divided by sine 3. So I got this to be like 4.49. But I'm just gonna take it times sine 31. And the height of that building is 2.31 miles. How about that? 2.31 miles. Okay? Anybody else? All right, I'm just gonna pick one then. Number 4, I'm on Prequest. Find the largest angle of a triangle whose sides are 9, 11, and 15. So I have a triangle, sides are 9, 11, and 15. I'll just randomly call them ABC. And I have to find the largest angle. Okay, where's the largest angle going to be? B? There are 3 things on this quest. Law sines, law cosines, area. That's it. This problem is going to be either law sines or cosines, because whenever you're finding a part of a triangle, you're going to use law sines or law cosines, one or the other. So which is this? It'll be cosines. So either on the end is going to be cosine B, and then what's going to be on this side? 15 squared. And then everything in the middle is going to be the 9 and the 11. So 9 squared plus 11 squared minus 2 times 9 times 11. Now be careful typing this in. Please do not get carried away and do all of this. You can't. You can do these two. So I've got 225 equals 11 squared plus 9 squared, 202, minus, I can multiply all that together, 2 times 9 times 11. Now what has has to happen next? I gotta subtract the 202. So I end up with 23, right? Yeah, equals negative 198 cosine B. And I can divide, so 23 over negative 198 equals cosine B. And what do I type in on my calculator? Second cosine, 23 divided by negative 198. 96.67. This problem, that's it. It wanted the biggest angle. If we had to solve the whole triangle, could we now use the law of sines if you wanted to? Yes, you could also repeat the law of cosines if you wanted, but you would have the option for the law of sines. But as it is, we are done. That was the largest angle. Everybody good on that? All right, how about number 6? Find the area and perimeter of a regular octagon inscribed in a circle with a radius of 4 centimeters. Okay, what does octagon mean? Octagon.
8.
8, thank you. So there's my octagon, and it has a radius of 4. Now, when you draw your radius, be sure you're drawing it like this. It's got to go to the circle. Don't draw it like this. That's not a radius. Anybody know what that's called? That's an apothem. Some people call it apothem. You learned that in geometry. Trust me, you did. Okay, so the radius is 4. So all these things are 4s. Now I want the area and perimeter. So let's start with area, because I think that's easy. Area of the triangle. Could I find that angle? I sure would like to know what that is. What is that angle? 45 degrees. 360 divided by 8. Now, the area of the triangle will be 1/2 4 times 4 times sine 45. Would you agree with that? So my octagon, is going to be 8 times the triangle. So 1/2 times 4 times 4 times sine 45 times 8. 45.25 square centimeters. Everybody okay with that area? Easy peasy? Now, perimeter. I don't think we've done that yet. Perimeter means this. Would everybody agree with that? Perimeter's the blue. Can I use a similar strategy and maybe find this right here, times it by 8? Now, that's a piece of the triangle. Law of sines, law of cosines. Which is appropriate? Yep, x squared equals 4 squared plus 4 squared minus 2 times 4 times 4 times cosine 45. Take a look at that, make sure that makes sense to you. And that one is easy to type in. That one is not tricky like this one was, because the variable's over here already. So just type it in. The only tricky part is, what do you have to remember to do when you get all this typed in? Square root. So I got 3.06, and then I'll hit times 8. So my perimeter, I think is 24.49 centimeters. Meg?
If you wanted to, could you take 180 minus 45 and then divide it by 2 to find the other two
Totally
tables and
could.
use the log line?
Because that triangle's isosceles.
Yeah.
You sure can. You sure can. Yeah. Alright, I'll just keep picking. 2C. Find the area of triangle CHS. I really, really want to do what you guys need me to do. I'm just randomly making up problems here. Find the area. Okay, area. No matter how you find area, 1/2 base times height, 1/2 side sine, or Hero's formula, you need at least 2 sides. I don't have no sides. So what am I gonna have to do first? Before I can find the area of this thing, I'm gonna have to find, well, I can certainly find angle S. And it's 80. And then I can use the law of sines to find another side. I don't care, you either gotta find H or C, which one do you want? H. So sine 80 over 16 equals sine 52 over H. Either one would be fine, you'll get the same answer, it doesn't matter, just pick one. We picked H. So now I can figure out what H is. And some of you are letting me do all the typing, okay. But remember, you have to be able to do this on your own. I got 12.80. Now, I need area. I have 2 sides. Area is 1/2 side times side times what? Sine of what? The angle in between. So I'm gonna have to use my 48. If you had found side C, then you would be doing 1/2 16C sine 52. Got it? You have to use the angle between the 2 sides. So whatever that is, that's gonna be the answer to the question. 1A. How many triangles are possible? What are my possible answers to this question? How many triangles are possible? It's either gonna be 1, 2, or 0, right? Well, what do? How do we decide? Sine 50 over 10 equals sine B, whoop, 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 star, 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 caution, caution, caution. Anytime you start out with sine B, that means you might have more than one answer, right? So even if the directions don't clue you in, if you write this down, you might have more than one answer. All right, so sine B equals 4 sine 50 over 10. So second sine. Did you get an answer? What'd you get? 17.84. So what that means is I have at least one. Could I have another? Could I have a triangle where that other angle B, the new angle B, this was the original B, 180 minus it, could that happen? No, that doesn't make any sense, does it? So therefore, how many triangles are possible? Just that one, right there.
Something I noticed was like if the angle, if like the angle found is less than the original angle, then it's never gonna.
Okay, you're right. That's a piece of stuff we could memorize if we wanted. I can't keep track of all that, but it's absolutely true. Absolutely true. All right, I'll pick another one in that section. How about D? 1D, how many triangles are possible? Well, won't we set this up exactly the same way? So you set it up, tell me what you get for angle B. By the way, how do we know if there are no triangles possible? Yeah, when you do this step right here, when you second sign, it comes up with an error. What did this one come up with? 38.81. So that means that if there is another triangle,
It's 36.81, sorry.
oh, it's 36.81? Okay. So then if there is another angle, B, another triangle, angle B, that will be 143.19. Is that doable? Will that work? It's not gonna leave very much for this,
It works.
but it doesn't matter, right? It's gonna be a skinny little triangle. Okay. All right, let's see, number 3, find the length of the shortest diagonal. Okay, so we have a parallelogram. It looks like this. And we have to find the length of the shortest diagonal. Now, is the shortest diagonal gonna be this one or this one? This is the one, right? Caution, caution, caution. That diagonal does not cut this angle in half. Please do not say these are 55s. They aren't. They're not 55s. The only thing I know is that if this whole angle is 110, this angle has to be 70. Because when parallel lines are cut by a transversal, consecutive interior angles are always supplementary. Okay, I paid attention in geometry. And I've done this for a long time. These are supplementary, always. These are not 55s. That is wrong. They're not 55s. Only in a rhombus is in a rhombus. But if that's 6, this is 10. So now I've got 6 and 10 and a 70 in between them. Now you're not doing area. You're finding that diagonal, which means either law of sines or law of cosines. Which is it? Which is it? I don't know anything about this up here. That's gonna be law of cosines. X squared, 6 squared plus 10 squared minus 2, 6, 10. Cosine 70. Guys, this should be the easiest quest you've ever taken in your life. Please pay attention. Take it seriously. I got 9.74. That probably has some kind of unit on it, inches. Okay? 2B. 2B is a triangle. The sides are 10, 12, and 14. And we're finding the area. How do we do that? That square root thing is called Hero's formula. And how does Hero's formula work? What do I have to do first? Add up the sides. In other words, we gotta find that perimeter. So our perimeter would be 36. Do not use 36. I have to use the semi-perimeter, which is a T. That's the number I use, so I write it down right there in my formula, 18. Then I take that 18 and do what? So 18 minus 14, 18 minus 10, and 18 minus 12. Multiply them all together, square root it. And I got 58.79. Square whatevers. Right? Alright, I'm looking at request number 2, still waiting on somebody to ask me a question. Okay, number 6 looks different on request number 2. Find Q. So you gotta be able to draw your triangles, kind of get the lay of the land here. So I've got a Q, an R, and an N. So there's my triangle, and I am finding side Q. That seems easy. Be a law of sines problem. So we'll figure out what angle Q is, or angle R, angle R. We'll figure out what that is. $51. And then sine 51 over 19 equals sine 48 over Q. That seems very easy. I got 18.17. How about you? Okay. Well, I thought it was different, but it's easy. All right, let's look at number 4. Another parallelogram. This time we are finding AC, which is a diagonal, and the area. All right, why don't you take a second and do that. See if you can get that figured out. We just did one like this. In case you need it, how big will this angle be? You might not need it, but if you do, how big will that be? That'll be 58, because these two always add up to 180. So if you need it, great. If you don't need it, you don't need it. That's fine. So we're missing Amanda. Did I do this okay? Anybody get those two answers? No? Did you type it in, Meg? You're just sitting there, like, you're just nodding your head. Did anybody type either one of these in and get either one of those? No? They're both wrong? Alright, so area, the area of that triangle, right, area first. The area of this triangle is 1/2 14/6 sine 122. And then I would double that.
Yeah, I got that. I got double.
Okay, why am I doubling it? 2 triangles. So I think that's right. I got it twice. For the area of the whole figure. To do AC, I did the law of cosines. And since I want that diagonal, I'm actually using that angle. And don't forget to square root it. I got that again, guys. I think that's the right answer. So if you're not getting that, you need to ask me what you're doing wrong. Alright, anything else on here? What's a nonagon? Number 3 refers to a nonagon. 9 sides. So that will be just like our octagon problem, only instead of 8s, we'll use 9s. Yeah, so the angle will be different. But that's okay. Decagons too. All right. Okay. All right, well, there's extra problems there if you want to practice. I've included some answers in that slide. Some of them anyhow. So, all right, tomorrow's the day. We have our quest. It will not be all period. It's only one piece of paper.
Is it tomorrow or Wednesday?
Next time we have class.